Section 11.4 is matrix algebra, so we're going to talk about adding, subtracting, and multiplying matrices, as well as finding the inverses and using those to solve systems in another way using matrices. So we always label the dimensions of a matrix as their rows by columns. So go ahead and pause the video and write down the dimensions of matrix A. So matrix A is 2 by 3, it has 2 rows and it has 3 columns, so we call it a 2 by 3 matrix. So if we want to add matrices, whenever you add matrices, you have to have the same dimensions. So to add or subtract matrices, they have to be the same dimensions. So if we want to add A plus B, these are both 2 by 3 matrices, so we can add them. And then to add matrices, you just add each individual entry. So for the first one, we have a 2 plus 3, so the first entry, 1, 1, is a 5. For the next one, you have a 0 plus a negative 2, so the next entry, 1, 2, is a negative 2. And then the last one on the top row, you have a negative 2 plus 6, so the last entry is a positive 4. So go ahead and pause the video and fill out the bottom row. So you should end up with 5, negative 2, 4, 1, 5, negative 9. So when you add or subtract, you just add or subtract each entry individually. You can also multiply a matrix by a constant. So for instance, we have here 2b. So when you multiply a matrix by a constant, you just multiply every entry by that constant. So matrix 2b would be 2 times the matrix b, which ends up being 6, negative 4, 12, 0, negative 6, negative 8. So multiply 2 by each entry. Now we want to subtract off matrix A from that. So go ahead and pause the video and subtract matrix A from matrix 2b. So just like before, you're going to subtract each individual entry. So you end up with 4, negative 4, 14, negative 1, negative 14, negative 3. So whenever you add or subtract matrices, they have to be the same dimension. So in this case, they were both 2 by 3. And to multiply by a constant, you just multiply every entry by that constant. We can also multiply matrices together. So when you're multiplying matrices together, if you have two matrices, A and B, and A has the dimensions m rows by r columns, and B has the dimensions r rows by n columns, then when you multiply A times B, you get a matrix that's m by n. So when you're multiplying matrices, you want to set up the dimensions in the order that you're multiplying the matrices. So this is A times B, so I put the dimensions of A times the dimensions of B. To be able to multiply these matrices, the inside dimensions must be the same. So the columns of the first matrix must be equal to the number of rows of the second matrix. If that's true, you can multiply them. If that's not true, you can't even multiply them. If you can multiply them, then your resulting matrix will be the size of the outside dimensions. So if I were to multiply these matrices together, then I would end up with an m by n matrix. So the biggest thing is when you multiply matrices together, the inside dimensions, so the columns of the first and the rows of the second, must be the same value. So here we have two matrices, A and B, and I want to multiply matrices A times B. So when I set that up in that order, I have a 2 by 3 matrix times a 3 by 2 matrix. So my inside dimensions are the same, which means I can multiply them, and my resulting matrix is going to end up being a 2 by 2 matrix, the outside dimensions. Okay, so the insides match, I can multiply them, my resulting matrix is the outside dimensions. When we multiply matrices together, it's not quite as simple as adding, where you just add each entry. You actually multiply the entire row of the first matrix by the entire column of the second matrix. So if we want to find the entry that's in the first row, first column, then we multiply the first row of the first matrix by the first column of the second matrix. So the way that we do that is we multiply each entry. So we're going to multiply the first entry by the first entry, so 2 times 1. And then we're going to add the second entries. So in this case, 1 times 2. And then we're going to add the third entries. So in this case, 3 times 3. And then multiply and add all those together, and we get our first entry, 13, of our resulting matrix. So we multiply the first row by the first column because we want the entry that's in the first row, first column. And then we multiply every entry in its spot and add them together. So now if we want the one that is in the first row, second column, we're going to multiply the entries that are in the first row by the ones that are in the second column. So same thing, we're going to have the first entry, so 2 times 0. And then we're going to add the second entries, so 1 times 1. And then we're going to add the third entries, so 3 times 2. So our entry in the first row, second column ends up being a 7. So now we want to find the entry in the second row, first column. So we're going to multiply the second row of the first matrix by the first column of the second matrix. So go ahead and pause the video and try that. So you should end up with a -1. You end up with 1 times 1 minus 1 times 2 plus 0 times 3. So you end up with a -1. So now go ahead and pause the video and find the last entry. So when you multiply the second column by the second row, you should end up with a -1 again. You get 1 times 0, -1 times 1, and 0 times 2. So whenever you're doing matrix multiplication, it's always row times column, and if you want whatever entry you want, so first row, first column, you multiply first row, first column. If it's, second row, third column, then you would multiply second row by third column. So now let's look at B times A. So this is switching the order. So instead of having the 2 by 3 matrix first, now you have the 3 by 2 matrix first. So first we have to check, are the inside dimensions the same? So are the number of columns in the first matrix the same as the number of columns in rows in the second matrix? Which they are, so we can multiply these together. So then your resulting matrix is going to be the outside dimensions. So this matrix is actually going to end up being a 3 by 3 matrix. So what you should notice is even though we're multiplying the same matrices, just in the opposite order, already this was a 2 by 2 matrix, and down here we're going to have a 3 by 3 matrix. You can already tell they're not going to be the same. So unlike regular multiplication, matrix multiplication is not commutative. A times B is not the same thing as B times A. So now let's try this one. Again, if we want the entry that's in the first row, first column, we're going to multiply the first row by the first column. So in this case, we have 1 times 2 times plus 0 times 1, so we end up with a 2. So now if we want the one that's in the first row, second column, you're going to do the same thing. You're going to multiply first row by second column. So for this one, you're going to have 1 times 1 plus 0 times -1, so you end up with a 1. So go ahead and pause the video and find the first row, third column. So you should end up with 1 times 3 plus 0 times 0. So first row, third column ends up being a 3. So go ahead and pause the video and finish out the second 2 rows, or the next 2 rows of this 3 by 3 matrix. So the second 2 rows should be 5, 1, 6 and 8, 1, 9. So second row, you're multiplying second row by whichever column. So second row by first column for here, second row by second column for here, second row by third column for the last one. And then same thing with the third row, you're always doing third row by whichever column place you want. So in matrices, we have an identity, just like we do in regular addition. 0 is an identity for addition. Anything plus 0 is itself. And 1 is the identity for multiplication. Anything times 1 is itself. We have an identity matrix. So it's a square matrix, so 3 by 3, 2 by 2, 7 by 7, with 1s down the diagonal from upper left to bottom right, and 0s everywhere else. Also in matrices, we have inverses. So just like in regular multiplication, where if you multiply a number by its inverse, or its reciprocal, then you get the identity, or 1. Same thing with matrices. If you multiply a matrix by its inverse, you get the identity matrix. So there's a couple ways to find an inverse of a matrix. One way works for any size matrix, and then there's a shortcut for 2 by 2 matrices. So I'm going to show you the shortcut for 2 by 2 matrices. So if you have a matrix, a 2 by 2 matrix, A, B, C, D, then inverse is 1 over the determinant, so you have to find the determinant of this 2 by 2 matrix, and then the matrix is you flip A and D, so you flip this upper left to bottom right diagonal, and then you make B and C negative, so you make this side negative. So now let's find the inverse of this matrix A. So first thing, go ahead and pause the video and find the determinant of matrix A. So you should end up with a determinant of 1. You get 3 minus 2, so that equals 1. So now go ahead and use this determinant to find the inverse of matrix A. So inverse of a 2 by 2, 1 over the determinant. In this case, the determinant is just 1. Flip this diagonal, so I switched 1 and 3, and then make the other two opposite signs, so they become both negative in this case. So your resulting matrix is 1, -1, -2, 3. That's the inverse of matrix A. So we're going to use inverses and matrix algebra to solve systems of equations. The way that we're going to do that is if you think about this equation here, and I asked you to solve for solve for x, what would you do? Most of you would probably say you divide both sides by a, which is the same thing as multiplying by the inverse of a. So if we multiply that side by the inverse of a, we also have to multiply this side by the inverse of a. In matrix algebra, it matters which side you multiply it on, so I have to multiply it on the left side here, so I have to multiply it on the left side here. So a inverse times a, that just becomes your identity, so basically it goes away. You're left with just x is equal to the inverse of a times b. Well, that same idea is going to relate to these matrices, where A, matrix A, is going to be your coefficient matrix. So in this case, it's going to be 3, -2, -1, 1. So just the coefficients of your x's and y's. And then matrix B is going to be your answer matrix. So in this case, it's just a 2 by 1 matrix, 8, 4. X is the 2 by 1 matrix, x, y. So first thing we need to do is find the inverse of matrix A. So go ahead and pause the video and find the inverse of this coefficient matrix. So to find the inverse, we have 1 over the determinant. The determinant ends up being 3 minus 2, so again, it ends up just being a 1. And then flip your 1 and 3 and make -1 and -2 the opposite sign. So in this case, you get 1, 1, 2, 3. So that's A inverse. So what we're going to do is we're going to multiply A inverse times B. So we're going to set up the equation x, which is the matrix xy, is equal to A inverse, which we found, times B, which is the answer or constant matrix. We're going to multiply a 2 by 2 matrix times a 2 by 1 matrix, so our inside dimensions are the same, which means our resulting matrix is going to be a 2 by 1, which is what we want to match our xy matrix over here. So go ahead and pause the video and do that matrix multiplication. So when you multiply rows by columns, first row, first column, 1 times 8 plus 1 times 4, you end up with 12. Second row, first column, you go 2 times 8 plus 3 times 4, so you end up with 28. So you end up with the matrix 12, 28, but you know that's equal to the matrix xy, so therefore x is equal to 12 and y is equal to 28. So when you're solving using inverse or matrix algebra, you have your coefficient matrix, you take the inverse of that, and then you multiply that by your answer matrix, and that will give you your answer.